Beyond the outermost planets, where the Sun has faded into little more than a distant point of light, lies a region of space unlike anything humanity has ever explored. It is a realm where the solar wind no longer dominates, where temperatures plunge toward absolute zero, and where silence stretches across unimaginable distances. Nearly 24 billion kilometers from Earth, a lone spacecraft continues drifting through this darkness, carrying humanity's presence into the unknown. That spacecraft is Voyager 1. Launched in 1977, Voyager 1 was designed for a mission expected to last only a few years. Its purpose was to explore Jupiter and Saturn before its systems gradually failed. No one imagined it would still be operating nearly half a century later. Yet against every expectation, the aging probe continues to communicate with Earth, sending faint signals across billions of kilometers from interstellar space. For decades, those transmissions followed a familiar pattern. They contained measurements of magnetic fields, charged particles, cosmic radiation, and the environment beyond the edge of our solar system. Every message expanded humanity's understanding of a region no spacecraft had ever visited before. Then, something changed. The newest transmissions no longer looked completely ordinary. Hidden within the familiar stream of engineering data were unusual patterns that immediately caught the attention of mission specialists. At first, they appeared to be nothing more than random interference, the kind of distortion expected from an aging spacecraft operating in one of the harshest environments imaginable. But the anomalies refused to disappear. As engineers examined the incoming data more carefully, they noticed repeating sequences that appeared far too organized to be dismissed as simple noise. Instead of random fluctuations, the signals followed remarkably consistent timing, suggesting an underlying structure that nobody expected to find. Soon, additional irregularities began appearing throughout Voyager's telemetry. Measurements from systems that had remained stable for years suddenly behaved in unexpected ways, while other instruments reported values that challenged long-standing assumptions about the spacecraft's condition. Individually, each anomaly could have been explained as the result of aging hardware. Together, however, they formed a pattern that demanded closer investigation. One of the most surprising discoveries involved a thermal sensor that engineers had long considered inactive. Without warning, it began transmitting data again, reporting subtle but repetitive temperature variations. Even more puzzling was the regularity of the changes. Instead of fluctuating randomly, the readings followed a precise cycle that repeated over and over, suggesting an unknown influence acting on the spacecraft. The mystery deepened further when analysts compared recent communications with earlier records. They found that certain radio bursts contained harmonics unlike the signals Voyager had produced throughout the rest of its mission. Rather than appearing chaotic, these frequencies displayed an unusual level of order, prompting researchers to investigate whether the source lay within the spacecraft itself or somewhere beyond it. For a probe built using 1970s technology, this behavior was difficult to explain. Voyager 1 possesses only a tiny fraction of the computing power found in even the simplest modern electronic devices. It has no artificial intelligence, no ability to rewrite its own software, and no advanced autonomous systems capable of generating entirely new forms of communication. Every transmission should follow predictable engineering principles established decades ago. Yet the latest data seemed to challenge those expectations. As investigation continued, another curious observation emerged. Some communication sequences appeared to align with ground transmissions in ways that were difficult to explain through ordinary signal delays alone. Although engineers searched extensively for technical causes, the unusual timing fueled growing speculation that something unexpected was influencing the spacecraft's communications. Then came an event that attracted even greater attention. Voyager 1 performed a series of subtle course adjustments using its remaining attitude control system. While small corrections are sometimes necessary to maintain antenna alignment, These maneuvers appeared different enough to encourage detailed analysis. Mission controllers transmitted updated commands, carefully monitoring the spacecraft's response while attempting to determine the reason behind the unexpected changes. As scientists reconstructed Voyager's projected path, they discovered that the probe's orientation now appeared to favor a region of space that contained no obvious destination. There were no nearby stars, no known planets, and no familiar astronomical objects capable of explaining the shift. Yet observations suggested faint radioactivity originating from that same direction, sharing characteristics remarkably similar to the unusual signals already detected within Voyager's own transmissions. For the first time in decades, one of humanity's oldest spacecraft had become the center of a mystery that nobody could confidently explain. Whether these strange observations ultimately proved to be rare natural phenomena, unexpected spacecraft behavior, or something entirely unforeseen, Voyager 1 has once again reminded us that the frontier beyond our solar system remains filled with unanswered questions. Even after nearly 50 years of exploration, the greatest discoveries may still lie ahead, hidden within the darkness between the stars.